Today, I'm having a conversation with Ed Mehr, the founder and CEO of Machina Labs. Machina is building highly automated, flexible factories that are run by networks of programmable robots. They call it a robotic craftsman platform. Now, I first came across Ed's work when I was looking into new next generation manufacturing models. And what caught my attention was the question that the company set out to answer, which is, can you build a factory flexible enough that it doesn't need to change even though you change the product that it's making? That question instantly had me hooked because instead of just layering on robotics and automation to how a factory works today in our centralized system, Ed and his team have completely reimagined this from the ground up to build manufacturing in a much more decentralized and flexible way. Ed's vision is to have a network of these decentralized facilities and factories making a variety of products on demand. He thinks about Machina as a data center for physical goods. Bullseye for going direct. So, Ed's worked at some generational defining companies, including Microsoft, SpaceX, and Relatively Space as an engineer. He's building something really interesting that really has a shot to help reinvent manufacturing and define the future of American industry. I hope you enjoy the conversation, and remember to go direct. Well, hey, Ed, man, thanks for taking the time to come on to the pod.
No, I'm excited to be here. This is a great conversation topic, so happy to dive in and talk about it.
Great. So, and listen, it was I heard in an interview that you did not too long ago. I'm gonna actually have to read it here because it was like when I heard it, I was like, okay, I got to have a conversation with Ed. But when you were talking about the core question you guys are trying to answer with Machina Labs, I'm going to read it right here, but can you make a factory that doesn't need to change every time you change the product you want to make? And so when I heard that, I was like, okay, we need to have a conversation because I think we could talk for a long time about this stuff. So, but I want to start with something pretty foundational. So in your mind, what's the core problem with manufacturing today?
So I think it depends on at what layer we are talking about. Mm-hmm. I think from the perspective of just the fundamental layer, like what is even manufacturing about and how good are we at achieving what it's about, right? So a fundamental layer, I think, manufacturing is one of the true art forms, right? It's the process where we make things. We control the environment, turn and mold physical things into things that we want, and it's expressive of what we desire the environment to be like, right? So at core, I almost equate it to almost freedom of expression.
Okay.
In terms of you're actually expressing yourself. We as humans are expressing ourselves in terms of how we want to shape our environment. So to me, that's what manufacturing is about, forming and shaping the physical world in a way that's useful to us. And that's how it's always been. Manufacturing used to be arts and crafts. And then through industrialization, we got to the point where we have factories, but the challenge is that these factories can make the same thing over and over again. So we kind of lost a little bit of that expressiveness, right? That's why when you're you get excited to go buy a piece of art that may be built by some craftsman or some artist somewhere, because there's a little bit of soul of that artist got into that piece. And that's why it's attractive, right? It is not just a product you use, it's expression of what that artist wanted to create, right? Mm-hmm. So we've lost that a little bit with the mass manufacturing. So at core, I think one challenge that we have is manufacturing is a little bit has been detached from its initial purpose, which was expression, right? Being able to form and shape environment in ways we want. Now, if you are a new, younger engineer who want to do that, who want to express yourself through making things, you are so far removed. You need so many means of production before you are able to do that. That I think that core idea of manufacturing is a little bit lost. So at core, I think that's what's a little bit wrong with manufacturing. If you're a young engineer today, your only way to express yourself in this physical world is join these massive companies that have the resources, that have the factory to turn your design ideas into something that's going to be produced. Right? I joined SpaceX. Other people in that company joined Fords and Hondas of the world. Right? So that's, I would say, at the highest level is the core problem, and then we can kind of get to some of the more practical problems that we have now. But even at that core level, I think a lot of people get disenchanted when they realize, okay, I got into manufacturing or mechanical engineering because I want to build cool things, but now I need to jump through a whole bunch of hoops go to these giant companies, put together facilities before anything even comes out, and it's possible to be used, right?
Yeah, it's interesting though, but when you kind of, oh, we'll get into it, but how miraculous really kind of this last industrial revolution has been though, when you think about economies and scale and being able to produce affordable goods, right? So that's kind of like the other side of this thing. So, but
Right.
we'll get into it. So I've also heard you say, one of the challenges that you see now with manufacturing is kind of is iteration cycles. And so why are fast iteration cycles so important in manufacturing?
Yeah. Um, I mean, that's at core, obviously, it's like, you want to make the things that you want to make as fast as possible, right?
Mhm.
So there's that desire. But practically, you want to get it to the market as soon as possible. You look at and get feedback and update it and make it better, right? So if you look at, some of the industries that have been maybe the fastest moving industries in the past few decades, most of them are in software,
Yep.
right? And if you want to think about why is that? Why is software so has made leaps and bounds in the past few decades? We went from like 1980s to have these supercomputers that nobody really had access to now on your phone you have almost a living person that you can talk to, right? And everybody has access to that. So why did that happen? And I think the main reason was speed of iteration. Anybody with any idea on the software side could develop it on their own computer, right? They need anything but just a computer. A group of people on a computer could could create a software, and then they could just rent server space in Amazon and AWSs of the world, and immediately the next day provision whole millions of servers, hundreds of thousands of servers in a day, and deploy it to millions of people. And if that idea was good, it would take
Mhm.
off. You look at companies like TikTok or some of the other companies, they got from zero to millions of users days. Sometimes now it's getting to a point that it's hours, right? So you can put something out and hours later, millions of people are using it. With hardware, it's still months and years, right? So that development cycle doesn't allow for feedback, doesn't allow for the speed of innovation is directly correlated with your development cycle. So if that is too long, that means your speed of development is slow. We were promised back in the 50s and 60s, oh, we're all going to have flying cars and they're going to be a base in the moon and all that stuff. But then instead we got Instagram and TikTok, and we're still driving almost the same cars with like a little bit of add-on to it, right? And that's I think at core is the issue of slow speed of innovation, which is the issue of slow iteration cycles.
Okay.
So that's core, but then in a lot of other applications, that low iteration cycle means there's other disadvantages. For example, in repair, if you have low iteration cycle manufacturing something, then if something breaks, you cannot easily change it. So there's other effects, but at core, it's about a speed of innovation.
And I want to go off a little side tangent, um, real quick, because I heard you also say something about, obviously I know you're a space nerd, and how for you it's really important that we make things in space,
Right.
and it's an interesting perspective because a lot of people who are just not knowledgeable or might not be thinking about it are like, hey, we have plenty of problems here on Earth. We should just be focusing on stuff on Earth. So can you just talk to me a little bit about why you feel so strongly about building infrastructure to be able to make things in space? So people
Yeah.
like the naysayers or people that might be thinking about why are people even doing this, why they are doing it. So
Yeah. Well, I mean, like, I think the most immediate practical answer is that like development in the space will improve things on Earth, right? That's a textbook answer of why NASA exists from when I was a kid in school, right? Like that. Oh, like the pen that you use actually was developed by initially for some space application, right? So there is when you push the boundary, when you try to go to these hostile environments and do things, you end up coming up with things that end up being used on Earth, right? So that's kind of the textbook answer. I think there's also a kind of human level answer is that we are on a small mote of dust in a giant galaxy, in a giant actually solar system, which is in a giant galaxy among billions of other galaxies, right? So I think if you widen the aperture a little bit, like Earth is a very small place compared to the rest of the world. I think there's that mentality of abundance is sometimes missing, from these conversations. Yes, Earth is great, and we love the planet that we live on, and we should maintain it, and we should be good stewards of this planet. But it's like fraction of a fraction of a fraction of a fraction of the resources that are available in the universe, right? So it's like we found this really shady tree that we were under it, and we are like, okay, great, but then there are billions of trees out there, and we're like, well, but this tree maybe we need to fix it, we need to make improve it, and we should, but there's also other trees, right? So I think so that there's that fundamental, just you widen the aperture, there's just so much more opportunities. And then the last piece is, there are, for example, I give you a very tangible example. Right now, a lot of stuff we use in electronics, in batteries, in a lot of high-tech devices that we use things called rare earth metals, right? These are, by definition, very rare on Earth, right? And they're not so rare in the space, right? So if you go to asteroid belt, you can find some actually plenty of them, right? So there are also resources out there that we do need to use here on Earth. So we need to go extract those, and we need to turn them in situations where they're actually usable before we can bring them back to Earth, because that might be more efficient on how we bring them back to Earth that way. But more importantly, then in order for us to go get these resources, we need to build capability outside of Earth so that we can actually harvest and take advantage of these kind of resources that exist outside. And one of those core capabilities is manufacturing. If you send something to Mars and you can repair it, if you send a facility or a spaceship or a shelter into Mars, and you have no capability to repair it, and it takes you 2 years every time to go back and forth to Mars, you really cannot do much there, right? So some of these fundamental capabilities in terms of building and manufacturing need to exist in space for us to be able to be multi-planetary species, and also bring these kind of rare earth metals and the resources, generally rare earth resources, back to the Earth.
Why do we have to be multi-planetary species in your mind?
Well, I mean, there's plenty of reasons. I mean, some of it just what I just said, right?
Sure.
We're under one shady tree, and there's many other trees out there. But I think the core argument is, so I think the main argument for me as human level is why not?
Okay.
Right? Why did we go climb Everest? Right?
Sure.
Because it was just there, right? It's like a famous thing from JFK. It was like, we climbed Everest because it was there, right? We went to the moon because it was there, right? So at core level, we are explorers,
sure,
right? As a species. So I think we're just not going to be happy sitting here. Like, we need to go find these planets and explore the rest of the universe, which is orders of magnitude larger than what we have already discovered. Why did we even came to America, right? When we were back in Europe, why did people make the very crazy voyage across the Atlantic to come here, right? We are now sitting here, and you and I are talking, and we consider this our country, right?
Sure.
So at that fundamental level, I think it's just a human innate nature. But then the other piece is also like to just hedge our bets. Right? We have one planet. We need to be a good stewards, and we need to take care of it. But we need to make sure we have a backup plan, right? We need to go to other places, right? And just fundamentally, like we need to have a backup plan because of the things that might happen to this planet that's outside of our control.
Sure.
Right? It might be hit by an asteroid. There's so many other things. There might be cataclysmic events that, like, even outside of our control. I mean, ask dinosaurs, right? Like, they don't exist anymore, right? So like, and it wasn't anything they could do about it, right? So at some level, I think, it is important to have backup plans if you want the human species to survive.
Yes, there's something else here that I think is like really important, which is, it's kind of like also like going back to your point of like the innate desire for humans to explore, is also to dream, right? To dream and to expand and to, I don't know, to dream, to do amazing things and progress the human race. And I think we're just so stuck and focused on these small little things that happen every day that don't really matter in the big picture. And you have people who just sit there and pick at small things and waste all their time versus, I don't know, putting their mind to something much more aspirational. I don't know, but.
No, I totally agree. I think it's also comes down to that mentality of, Are you thinking from abundance? Are you thinking from
Totally.
the universe has so much to offer? Or are you coming from a fear-based mentality of, well, I need to protect all the nuts that I gathered so far,
True.
right? Versus like, oh, there's millions of nuts out there that we can go gather still, right? I think there's a little bit of that too, and it's easy to become fear-based. Like, it's easy to kind of like, yeah, close the aperture, just look at what you've done and what you have, and try to be protective of it. And unfortunately, I think if you look at the history, if that is not the best way to survive, right? You need to have some backup plan. You need to go out there and find more as well.
It's interesting. My wife is French. I spent a fair amount of time in Europe, and I really noticed this. Like, right, it's really I really use the comparison that you speak to Americans in general. It's like the mindsets around abundance, and over in Europe and France specifically, it's definitely a much more of a like a mindset around scarcity, and like that affects everything. Like it's
Yeah.
very interesting. Like there's good and bad to both, but so I can resonate with what you just said. All right, so let's move over to Machina. Can you explain what a robotic blacksmith army is to the
Yeah.
audience?
So, so a robotic blacksmith, or what we call a robo craftsman, is a robotic system that can do different manufacturing operations, um, um, if you ask it, basically, right? Think of it as a basically intelligent robotic system that's built for manufacturing. You can ask it to form sheets, it will form sheets. You can ask it to weld, it will weld. You will ask it to do other manufacturing processing, it does. So the idea is you have this robotic system that works like a robot craftsman, right? It can pick up different tools, apply it differently to material, do different things, and make different types of parts out of different feedstock. Now, if you have that system, that robotic craftsman, right, and you can scale it, you can create, horizontally make a lot of it, scale it horizontally. Like you have a facility that you have 200, 300, 400 of these in there. Now, collectively, you have a manufacturing facility that you can ask it to do different things at a higher throughput, right? So what we think of a robotic craftsman is a kind of core unit of manufacturing that allows us to build flexible factories, right? A robotic system can do any operation. You scale it horizontally. Now you have a factory that can, build any parts. You can build aircrafts in the morning and car parts in the afternoon, and that fundamentally solves the problem we talked about before. Is that okay? That we kind of go away from that inflexible manufacturing that
Mm-hmm.
that needs to be just giant facility that can make one thing over and over again to a facility that's programmable. And going back to the analogy that we had in the beginning of the conversation, this is kind of the same as what data centers did to the computation world, right? You have a facility that has a lot of manufacturing cells. These manufacturing cells can be programmed to do a lot of things. It's the same as you have a data center that has a lot of computers in it, and the computers can be programmed to do different types of a computational workloads. Some of them can be web servers, and some of them can be doing AI workloads, and some of them can do some other kind of computation, scientific computations, right? So really, we're trying to create that same paradigm that gave flexibility to the computation world in the physical world. Some people think of Robo Craftsman, they call it a material compiler or a matter compiler, right? It's a
Mm-hmm.
unit that can turn any input matter, a feedstock, to other types of input matter that are more useful. That's what we're doing. Obviously, we are in different phases of development. Right now, we mostly deal with sheet metal. But the idea is that over time, you can also deal with different types of material, different types of feedstock, and generate all kinds of parts.
Got it. And why? Just curious, what was the reason for starting with sheet metal?
Yeah, so sheet metal, it's kind of interesting, right? Whole bunch of things. So there was two things that I was thinking of. One is, you start a company like ours, which we have a very ambitious goal, right? We say, okay, this factory can build anything in the future, right? We
Mm-hmm.
need to find from an application where we have a lot of opportunity to grow market share and generate revenue, right? So sheet metal is the largest metal processing sector out of all. And if you think about it, intuitively makes sense. Most of the times we use metal things to create enclosures. That means it's like a thin metal structure that encloses other things.
Mm-hmm.
And that's why sheet metal is so widely used. You think about, you're sitting in a freeway, you're in a sea of sheet metal, right? Everything around you, all the cars, the body of them is basically formed sheet metal parts. You're sitting in an aircraft, you're in a sheet metal can. Um, you know, in the building, if I go outside, all the tubing for the HVAC are all sheet metal, right? So it's the largest metal processing sector, allows us to get a very good foothold in our first application and then expand to the other applications, right? And then why specifically, well, that's why specifically metal has become this kind of like very widespread phenomenon, because metal is one of the most, if you think about a material that's versatile and it's abundant, and you want to have a material that's like the most common of both, like it's very versatile, it's very abundant, you land on metal and the form is going to be sheet, right? In the universe, we have ceramics and we have composites, but they're either very hard to make or they don't have enough good properties to make useful stuff out of them. So metal, and specific sheet metal, kind of sits on the highest level of usefulness times abundance in the universe, right? So that's why we started from there. But we are planning to do other things as well. Like we're already working on some composite work. We're already looking at bulk form metal, like forging. So there's other processes that we're going into. But sheet metal was a very good, large market to start from.
Got it. And so where are you at now? So you have two facilities, is that right?
Yeah, so we have two facilities here in Los Angeles.
Okay.
Roughly 110,000 square feet. But we manufacture our systems here. We also run our systems and manufacture parts for the customers. We're in the process of making our third facility, which is a 50 plus Robo Craftsman cell. That might not be in LA. But we also deploy our systems to customer sites. So, for example, the Department of Defense is one of our customers. We have deployed our manufacturing cells, our Robo Craftsman, to their facilities, and they're using it to repair weapon systems and aircrafts when they get damaged. So we do both. So it's both in our facility and we deploy it outside.
Okay. And when you deploy it to your customers, are you who's actually managing the machines and
Yep.
running the machines? Are you training them, or is it your team?
Yeah, so it's a combination, right? So there's certain responsibilities we transfer to our users. So there's basically, I would say, like there's two set of categories. One is just running the machine and making parts. So that usually we train our customers on. And then the other one is creating recipes of like, how do you make a certain part? That's still in-house. It's done by our team. So we have like these tiger teams with our customers. But the goal is that long-term, in the next 2.5 years, we're going to transfer some of that function as well, kind of like come and go with the recipe for the part also to the customer.
Got it. In your mind and your vision for this, is the idea to be deploying these on customer sites everywhere, to have your own network of facilities? I mean, kind of trying to understand the vision for what this is in 10 years.
Yeah, so I think in 10 years, what I would like it to be is, you as a designer can go to a website and then get guided through how to make the physical product that you want to make, right? And this can be either like human guidance or like AI-based guidance, a topology optimized kind of like guidance on how to make a more performant part that is also manufacturable. And then you will say, okay, I want, 5,000 of these next month in Detroit, right? And the right facility in Detroit that is either operated by us or one of our partners gets programmed to manufacture those parts for you and starts manufacturing it on demand and send it to you, right? So that is the long-term vision. Now, so that means both they're going to be facilities that we're going to operate, and they're going to be facilities that's going to be operated by our partners. But the interface to the outside world would be the software piece, right? That you can just log in. You can be a graduate student or an undergraduate student in the school, or you could be an engineer at SpaceX. You can log in and then just submit your design and get it in a matter of hours or days after it's being manufactured in the facility that makes the most sense to where you want it, right? Now, we wanted to make sure that the cell itself can be deployed very easily, so we can set up new facilities very easily. Right now, the cell, actually, the manufacturing cell, the Robo Craftsman, it actually turns into containers, right? So it actually closes itself and turns into two 20-foot container that you can easily ship it anywhere. It opens up once it arrives in the facility. It self-calibrates. Within the same day, it can make parts, right? And the idea here is you can spin up facilities pretty fast. You don't have to wait months and years. Any warehouse, anywhere, as long as you have power and you have air, you can take these two containers, put it next to each other, it opens up, it calibrates, same day it starts making parts, right? And that can be our facility or customer facility. And then the nice thing about this is like not only it's good for civilian application, but for a lot of like, for example, military application where you're going out in Pacific, maybe you're entering a conflict there, and you need to support your assets there in terms of repair or sustainment. You can kind of like go into one of the allied countries or allied locations in that region, and in a matter of few days, set up a repair and sustainment facility as well, right? So also wants to give you, outside of civilian application, we want to give this kind of agility and mission readiness to our some of our partners like military as well, so they can easily deploy a manufacturing facility in a matter of days.
Yeah, I get like the visual of like like the Transformers, it's like the thing just like opens up. What is the footprint then as it like opens up? What type of square footage are we talking about? Like full?
Yeah, so each system right now, and by the way, that picture, I just posted a picture of it closing.
Okay.
So that is on my social media if anybody wants to see it. Once it opens, it's like roughly 30 foot by 40 foot, kind of like a space. And then, you need like 16, 17 foot of clearance on the ceiling side. But yeah, and all you need is just, three-phase 480 power and air.
Yeah, so it's like pretty compact. And so what type of throughput is this thing? Can this thing produce per month? If it's, from a volume standpoint.
Yeah, so it depends on
obviously what you're making, but
what you're making, how big it is, right? A single part can take from minutes to, if a very complicated mic, can be hours. So I would say think of like hundreds to thousands in a month. So that's kind of roughly what the throughput is today. Okay. A lot of applications where we're working with right now at scale, they're looking at, a few thousand components a year. I think that's where we're roughly at right now in terms of like how much you can make with a system. Obviously, the speed of the system is about to increase more and more as we develop it further. So every time we kind of double the speed, the throughput also gets doubled, right? So.
And is it a can you make multiple parts in parallel, or is it more of like kind of a batch system? Like the system makes one part at a time?
So you could make multiple parts at a time. Well, the robots will be working on one part at each point. Like within each system, you can there won't work, but you can actually set up so that they're finished with one and go for the next and go for the next. And then because the cost of the system is relatively low, the way you get high throughput is you got to deploy multiple systems, right? And you got to run it in parallel.
Okay, got it. And your tech stack. So is this largely like the actual robot, like the actual machines? Is this largely off the shelf, and you're really integrating a variety of technologies together and building software on top to integrate it, or kind of walk me through that?
Yeah, no, that's a good question. So one of the things that we wanted to make sure is true for this system is that the cost of it is low and it's actually easily financeable, right? So we made a lot of conscious choice to be off-the-shelf equipment that can be used for other applications as much as possible, so that they're already commoditized, right? Even though maybe sometimes they were not the best fit, we went for something that commoditized so we can easily finance it, we can easily build it, and it's a reliable supply chain already existent for it. So I would say 70% of our hardware is off the shelf. 30% are things that we add to it. Obviously, we build the platform, we add end effectors that we build our own end effectors that we put, but like robots, sensors, as much as we can, we want to be off the shelf. 70% off the shelf. And then obviously the hard software is purely all built in-house.
Sure.
So what controls the system, what prepares the geometries and parts for the robots to process, those are built by us. So 100% on the software side, 30% on the hardware side. And we're hoping that we can even make that even less than 30%. Hopefully, if you can get 100% of it off the shelf, then that we're in a very good position in terms of scaling this operation.
Cool. And talk to me a little bit about how Machina was started. Like, what was your journey leading up to the idea? Just so kind of the audience gets a better sense of kind of your background.
Yeah, of course. So I started my career mostly on the software side, both like academically and in the industry. I was focused on machine learning, Um, but then eventually left academia and joined SpaceX. Um, so at SpaceX, I was a control engineer, controller software engineer. That's where I started getting kind of familiar with a lot of challenges we had on the manufacturing side, and how you basically have to build a factory every time you want to build a hardware product. Um, that got me really excited about some of the agile methods. So after SpaceX, I joined part of the early team, founding team of Relativity Space. And Relativity Space, basically, their goal was, okay, SpaceX, but let's all be agile manufacturing, and specifically 3D print, right? So that we can easily change design. It can easily go to another vehicle size or vehicle design and architecture. So I was there. I was in charge of the 3D printing team. So we built a very large envelope metal 3D printer that could print structures that were like 22 feet tall, 10 feet in diameter. That's where I kind of realized, okay, as great as 3D printing is, there are all these other types of processes like sheet metal forming, like forging, that also needs to be as agile. And 3D printing doesn't have, either economically doesn't have access to it, or is just physically not feasible for 3D printing to do parts of that those processes can do. So we started Machina to really create that platform that can be process agnostic. It's an intelligent platform that can do 3D printing if needed. It can do sheet forming if needed. It can do machining if needed. Really use the right tool for the right job, the same way a craftsman uses the right tool for the right job. It picks up a drill and puts a hole, but then it picks up a welder and does welding. Doesn't try to make everything with the welder like we did with 3D printing in the past couple of decades, right? So that was the journey that led into Machina. We kept trying to think, okay, what is that fundamental thing that gives us agility? And I think we're there pretty much at Machina. And it's that platform that's smart enough to do other processes without any change in hardware.
And there's obviously, which is great. I'm from Detroit originally, so and I've always been about moving. How do we move towards a more production oriented economy? It's been what my work's been about the past 15 years, and so I'm super excited in many ways to kind of see this push now back geopolitically, socially, culturally towards American manufacturing. But I see a lot of people in this space that are really just trying to like dump like automation and technology on the current like industrial current manufacturing model versus like rethinking it in a similar way I think that you are. And so can you tell me about your thoughts about, there's plenty of companies out there just trying to automate and operate under the current model and why that might be flawed?
Yeah. So yeah, I think I would say there's like, in this sphere of bringing manufacturing back to the United States and make us resilient from the production side.
Sure.
I think there are three types of ideas. I think one type of idea is, okay, let's just replicate what happened in the 40s, right? Bring back World War II type production, right? Back to the United States. And I think, okay, that's interesting, but I feel like, there's a reason that thing doesn't exist anymore. Our society has moved on from the quality of living that kind of economy had, to we basically just like have been accustomed to a different set of life now. So I don't think that is really feasible. There's a reason that's gone, and I think bringing it back doesn't necessarily gonna have a sustainable presence. It's not going to mean that it's going to stay for long. And we can, like with all kinds of government subsidies or whatever, we can maybe bring it back, but it's not going to stay. There's a reason it left. And then there's a second category that says, okay, let's just, to your point, there's like, let's just get the old manufacturing technologies from 40s, 50s, whatever, and then drop a bunch of automation in it. The problem is that's what we have been doing in the past few decades, I would say. And I think there's a limit to it, right? Inflexible automation has a cost to it. And it doesn't solve that fundamental problem where, like, okay, if something changes easily, can your factory also change as well, right? So yes, I think it reduces a little bit of labor, but it doesn't remove the flexibility problem. The flexibility problem is still there. We are inflexible. And I think a lot of companies in the past 20, 30 years have been doing that. So also the juice has been squeezed, right? Like in terms of how much automation can you put on top of old manufacturing processes. I feel like a lot of juice has been squeezed. If you look at car companies, they are a miracle of automation, right? In terms of like using the same old processes of stamping, welding, whatever, just put robots and try to make it as fast as possible. So we've already done that, right? So I feel like a lot of companies who come into that space, I think they're going against a very uphill battle, right? There's not so much more to squeeze. And I think there's the last category is like, how do we rethink manufacturing? How do we use these things that recently happened in terms of AI and in terms of kind of like being able to have flexibility in how we operate the robots? How do we reuse these type of new developments to rethink manufacturing? In a sense, a lot of people talk about us being behind China. In a sense, we are in front of China. China is doing what we did in the 40s and 50s and 60s, right? We're actually a little bit in front. So China is also probably following our footstep at some point. So what we need to do is now think about, okay, what does manufacturing will look like that nobody has ever seen, right? That's going to be a good fit for the next century and the rest of this century and next century, like where it can be deployed anywhere. It can be flexible. It can be as expressive as possible. It can go to space, right? I think that gives us a competitive advantage that nobody else can easily replicate, right? And creates us kind of this new powerhouse of manufacturing. Not just, well, let's do the things we did that China just followed up after us, and now we're trying to go back to the things that we did. Like, it just doesn't make sense. We have gone through that journey. Like, What is the next thing, right?
Yeah, it's interesting. I mean, you're really at a deep level, like describing obviously much more decentralized production. And so, one of my questions for you is, incumbent systems and economies are really hard to compete with. So how do you think about like the vision's something different, right? 30, 40 years down the road, but you got to actually meet the market where the market's at.
Right.
And so like, how do you think about building up in a more decentralized model that you're thinking about, but then being able to actually compete or outcompete the incumbents or the incumbent way of doing it?
Yeah. Well, one nice thing about the United States today is there's not a whole much of an industrial ecosystem left, right?
That is true.
So that's I mean, nice thing. I mean, it's a horrible thing, but it's a nice thing in terms of a new entrant, right?
Sure.
I mean, we were talking using so I'll give you an example, right? We're working with an aerospace prime, right? Creating bodies of a UAV. Over the past 40, 50 years, this prime has optimized itself to be a very thin layer of integration due to all the things that we have happened. Like, we started in the 40s and 50s, everybody was full stack, building everything. Finance people got in charge and started to optimize it in a good way. I mean, I think that was the play at the time. They started optimizing these factories. They're like, okay, let's create this very complicated supply chain of suppliers, 3-4 tiers of suppliers, and then we become just that thin layer of integration on top, and that way we're going to maximize our margins, right? So when we talk with the aerospace primes, they're like, okay, I don't have any more manufacturing. All I have is integration, right? So you have two options. You have a new technology that can manufacture things in a different way, faster way. We love it. It's faster, cheaper, great. I don't do any manufacturing, right? So
ironic.
Right. So go talk to my supply chain. Those are one of your options. Go talk to the supply chain. You go talk to the supply chain, and the supply chain is like, well, I'm operating on 10-15% margin. I have no interest. I don't have the ability or the talent or the people to make any changes. So no, thank you. I know this sounds great, but I'm going to stick with what I'm doing right now because I just don't have the means to change it. So there's an opportunity for us to come in and say, okay, we're going to be the supply chain. So I would just basically, long answer to your question is, you need to go as vertically as you can to deliver value today because of the arrangement that we have come into where primes are like thin layer of integration. The supply chain is weak and cannot adopt new innovation. So the companies need to come in and be as much as possible vertically integrated to deliver value. You have companies like SpaceX and Anduril who come like full-on vertical integration from start to end. I think there's opportunity to be smaller, like you'd be like some of the suppliers to the primes. That's where we are sitting there. but also like I think the opportunity to sell machines and technology to the supply chain is very bad. Like it just doesn't exist there, right? Like people don't have the capability, don't have the ability to integrate new technology. And then one last piece I was going to add to that is that you also, because as part of this vertical integration, you also need to go find what is their application. Like you cannot sell a technology. Nobody gives a shit about technology. And sorry, my language. Nobody cares about like, oh, your new robotic system is great and whatever.
Sure.
Like you need to actually deliver
Something.
UAVs. You need to do UAVs 10 times faster. You need to deliver something 10 times faster that the customer cares about. So I would say the other thing that I would say for the companies who are working on manufacturing technology innovations, you need to span the scope to the point where you're delivering a product in an application, and that is 10 times better than the alternative. That's how you're going to change the kind of compete with the incumbent.
You make an interesting point around obviously Anduril, SpaceX, and even obviously I put Tesla in here. Obviously, it's on the consumer side, but just going, like you said, full out ham, full vertical integration. You made this interesting comment of like going vertical, but then potentially not going all the way. And so, how do you think about how far to go as Machina?
Yeah, so I mean, we have been slowly expanding our scope. Honestly, I mean, this is like maybe. I'm giving our secrets to the customers to our competitors potentially. We don't have any competitors today, so it's all good. But the future competitors, and that's great. I think the more the better. But yeah, we started from like we're like, okay, we're just a technology company. Like here's what we built. Other people want. Right to the same issue you said. Right? It's like, well, nobody is going to integrate it because the incumbent is so entrenched in its current supply chain that like very hard to change the configuration of that supply chain and insert a new technology. So we went slightly bigger. I'm a big fan of Occam Razor. Like, just go as far as you can and don't take too much because then it becomes a distraction. But take as much as you can so that you can get the value of your product to the customer. And that's our thinking. So right now we're going after very specific applications. In those applications, I mean, these are large applications. Each of contracts in these applications could be $100 million a year for us.
Okay.
But we try to be as vertically integrated, not too much, as vertically integrated that we deliver value. In some of the application that is building a subassembly. In some of the application is building the full assembly. Some of the application is building the component. Very rarely it is you sell the technology.
And so just to make it less abstract for some folks who might not be as familiar, so can you just give a concrete example or just an example or two of your customers or how you're working with them with whatever you feel comfortable sharing?
For example, in the aerospace side, right, they don't want to sell because they don't do any manufacturing. They don't want the robotic system. They also don't want the parts because they also don't do the manufacturing themselves, right? They want to someone in the supply chain gets the parts and put it together. So the right level of integration for integrating with Prime was a sub-assembly level. Okay, can you make me the fuel tank for this UAV? And that's what I'm integrating. That's something I can consume, and you don't have to go to my supply chain, right? And the reason we stop there is because the person who has the money to pay for the technology is the person who's integrating it. So any further down in the supply chain, people didn't have the money or the margins to integrate a new technology. Went up enough to get to the customer that cares about the benefits of it. Oh yes, I can pay for this, and this is going to give me 4 times faster, and I can be more agile in the market when I'm competing with the other primes, right? But then we stop there. We're like, okay, we're not going to make the whole missile, obviously, right? We're not going to become Anduril, but we're going to make the fuel tank for it, and we're going to sell it to you, and going to have very good margins, and it's something that the customer can take. In another more vertically integrated industry like automotive, you work like somebody like, for example, Hondas of the world and Toyotas of the world, right? They have some manufacturing. So that layer was slightly lower. It's like, okay, we'll send you panels, you do these type of manufacturing on our car automotive panels, and then send it back to us. That's what we can consume. But we don't want the sell. We don't want the manufacturing. So almost in each of these verticals, you need to figure out what is the right business. But the good news is, each of these verticals can be, for somebody like ours, can be more than $100 million in revenue, right? So
Yeah.
it's worth
It's real
doing a
business.
slight exploration. Yeah, slight exploration, a slight customization to get to the point where the value gets to the customer. It's not like, a Honda comes in and says, "Oh, it's a $4 million business." It's eventually $100 or more million business, right? So it makes sense to do that kind of back and forth and exploration with.
Cool. And how many people do you have now?
We're roughly like 70 people now. We try to stay lean. I mean, we plan to get to 140. We constantly fight the urge to increase the team size. But we're right now at 70 people across the two facilities.
So this is one of the very one thing I wanted to ask you about as someone kind of on the ground. Obviously, policy. When you think about bringing U.S. manufacturing back in at scale, and when you talk about actually building the supply chains and
Right.
components of the supply chain, not the fully finished product, policy is going to play a big role here. And as someone on the ground with 70 employees, you're fighting every day against very large companies and incumbents, and you're inventing and you're creating. For the policymakers that are listening, what are like the one or two just like easy things or the most important things not that they could do to help companies like yours to actually, I don't know, help build a bigger ecosystem or give you a better chance of success?
Yeah. Okay. There's a lot of good advice that other people probably give. Make investment in these things, make capex investment a little bit easier. Those are the things our banks don't really support capex today. So all those things that other people will talk about. I give maybe another view, which is we are talking about how do we enable United States to lead manufacturing. So in the next few decades. Now, not to go back, but to lead, to be the frontier, to just say, okay, what is the future? What is the new mecca that we're going after, right? The beauty of it is that the government is one of the biggest customers of manufacturing today, right? Especially on the defense side. So I think they can play a big role in terms of looking at the strategy that we need to have to create next generation of manufacturing floors and start enforcing that on their supply chain to be like, I want this to be built. I'm one of the biggest customers. I want it to be built with these next generation that gives me an advantage. I want to make sure it's onshore. I want to make sure it's distributed. I want to make sure that it's agile. I want to make sure that even though it might slightly be at a slightly higher cost, and I don't think it will be, but even if it is, right? And not be like, okay, here's the final requirement, go build it however you want to build it. And I think that's just not going to change our manufacturing in any tangible, fundamental way, right? So I would suggest that, it's a little bit of counterintuitive suggestion, but I think in areas where government's one of the biggest customers, like defense, I think they can start asking for a strategy, that allows America to be in front, not just play catch up.
It's funny you said that. I've done a bunch of work in the biomanufacturing space, and I've been like shouting at the rooftops every time I meet folks, especially on the government side, where it's like the number one thing you can do is just procure.
Right. Right.
You are the biggest customer. You're the
right.
biggest. You represent the biggest business in the world, actually.
And procure in a way that like it gives us advantage, right? Like
totally.
I think a lot of people are just going to be like procure, like I can go procure it from China too, right? So, but they'll give us an advantage, like all these things we talked about, like what gives us a strategic advantage to the United States? How do we enable distributed manufacturing? Make that part of the requirement. Be like, if I'm buying a fighter jet, it needs to be distributed, manufactured. It needs to be able to has this type of a lead time. I need to be able to get it in less than X hours, and I need to be able to create a repair facility for it in a day anywhere in the world.
Yep. I'm going to move over to the technology side a little bit, and kind of the emerging technology side. Can you explain to the audience what a robotics foundational model is and why you're doing work in that, and that's why that work is so important in this space?
Yeah. So we talked about flexible manufacturing. We're creating a system that you can ask it to make any parts, and it comes up with a set of operations that makes that part. Now, that means the robot needs to come up with those operations and sequence of operations. Like every few milliseconds, what does it need to do next to achieve that part? And that's what robotic foundation models enable, right? The same way you talk to a chat GPT and it responds to you, and nobody sat down and programmed every word that needs to come after every word. It actually fundamentally figured out how to come up with language structures that responds to a question. That's what the robotic foundation is. Like in response to an ask, it comes up with the right sequence of operation without anybody programming it, right? To do that task accurately. You can go in it and say, hey, form a fuel tank for me, and it dissects it into the right set of subtasks, and then the operations for each subtask on millisecond level. What is the sequence of things it needs to do to make that possible? So it's almost equivalent of language sequence, but in robots world, right? The same way ChatGPT comes up with sequence of words, these models, these foundational robotics models, need to come up with a sequence of robotic operations. So that's a robotic foundation model. Yeah.
And where does that stand today? Like, are you working on your own and then using, a variety of open source libraries? I know there's been open source robotics modules been released. And I don't know, just kind of, I don't know. I'm a little further away from it and not technical, so it'd be helpful to understand the state of affairs.
Kind of like one of the kind of the edge of like AI ML space today, right? So there's not a whole lot of, there's some foundational models that people have built, but a lot of people who are working in space like ours, like other companies that are in this space, they're working on the models themselves, right? They're still building those foundational models. Now, there's some research work being done in like Berkeley and other places. So we can use some of that work. We co-write, papers with Northwestern, but it's still the early days. So we don't have like a giant Llama or a Chat GPT or whatever that we can build on top of yet. So, and that's why it's interesting, crucial to build these models. The main bottleneck today is data. How do we train these robots to do things? So a whole bunch of people are working in simulation world. The challenge with simulation is some of the processes are hard to simulate. For example, forming a sheet metal is actually very computationally expensive to simulate. So that gives our companies a little bit of advantage where we're forming a lot of sheet metal and we're gathering this data. So we actually have physical, real data versus, in the LLM world, you can just go scrape the internet. In our world, in the robotic world, you either have to generate data from simulation, which is very expensive, or you need to actually have robots deployed in the field and that are generating data. And that gives you a little bit of an advantage. But that's why it hasn't grown as fast as, kind of like language foundational models, because the data is not as readily available.
Yeah, I saw an interesting post not too long ago from another founder of another robotics company, and they were talking about exactly that, which is kind of when they were talking about vertical robotics applications, and they were just repeating exactly what you were saying. It's just like the data availability is just not there, and you have to like literally. They were saying, which is exactly what you're saying, which is like you basically have to create pretty much the robot, like a demo robot, to actually collect the data and do the actual thing.
And this actually ties into the question you had, like why the previous manufacturing technology is going to hit the limit, even if you put automation on top of it. Because are they generating data that allows us to have useful understanding of the environment to build these type of foundational model? A lot of all manufacturing process, even if you sprinkle automation on top of it, you don't have enough data of what's happening. You're not capturing enough data of what's happening to create this next generation of AI models. Versus with us, we build a process that every 4 milliseconds can know what is happening to the sheet, what is happening to the robot. We built this process with the data in mind so that we can capture that data. Sprinkle automation on top of old processes is still going to have data issue. That is, you don't have enough visibility to know what's going on.
Sure. Do humanoids play a role for you in kind of the vision for Machina, or no?
I think so. I'm excited. I'm personally very excited about humanoids. I think humanoids are, we have a lot of systems in the world that are built to interface with humans. So humanoid makes a lot of sense because we can kind of unleash these humanoids in the same spaces, and they gather the data the same way. They have eyes, they have ears, and build models, right? And we can also like teleoperate them because it's a very familiar form to us. I can wear a suit and put goggles on, and I can actually be a humanoid and train it, right? So, for example, if you go later on to Mars, You can't send humans to the surface, but you can send humanoids to the surface because of radiation. So humans can be sitting in the bunker, and then humanoids up can be driving, electric cars and manipulating the surface of the planet, right? And you can teleoperate. So there are like a lot of benefits to the humanoids. But I think the environments where humanoids going to be useful, there are some environments that they're just not going to be useful. Like for manufacturing is one of them. Right? Manufacturing, we have a constrained environment. What we need, and we already have robotic arms that give you the similar dexterity as humans, but then the benefit is they're more precise and they can apply more force, which is what you really need in manufacturing. And that's why we built them to begin with. We built all these tools like robots to actually accommodate for our physical limitation in terms of how much force can be applied and how accurate can we be. So I think there's some environments where humanoids would not be the first application that will be used. Manufacturing is one of them. Obviously, a lot of these humanoid companies are deploying in manufacturing environment, but I actually think we already have the kinematic freedom we want through robotic systems that already existed, like robotic arms. Plus, they have capability that the humanoid form cannot provide. What was missing is the mind, how these robots will do these creative operations. So, long story short, I don't think for us humanoids is anytime soon, but generally I'm excited about humanoids in other spaces.
Yeah, I think it's interesting. My perspective on it comes also just from just the labor bottleneck. Like when you took the realities of I'm just talking about in general of manufacturing and production, or just call it in production environments. You mentioned it about sending someone to Mars, you have to worry about radiation, but if it's a whole humanoid, and it's like it's so relevant across so many industries, and especially it's interesting, man, in the West because of all the rules and regulations and just around safety. It's just like I just think it unlocks so much, but to be determined. But I'm pretty excited about it.
That's a fair point. Safety in manufacturing is also like important. But but I think that the question becomes like, what is the right form factor, right?
Yeah, no,
I agree
totally
with you. The robot needs to be in those environments. But what form factor?
Cool. So one other thing I wanted to ask you about. So I'm a big fan of like history and always looking at how things have been done before. And it's obviously ironic that everything used to be decentralized, especially from a production standpoint. So I just wanted to ask you about, like, as you were forming Machina and as you're building it, like, how have you been inspired from the past because everything was inherently decentralized? Like, has that played a big role in how you like think about how you want to build this?
Yeah, I think fundamentally, I build Machina. I mean, obviously, like all these practical things that we talk about was a consideration. But really, at core, I think you need to build something that resonates with you personally, right? When I was in high school and earlier than that, I went to type of school that we did a lot of shop work, right? So I learned carpentry, I learned welding. So I really liked working with my hands and building things. To your point, that was my first exposure to manufacturing was this distributed nature. You could actually build things, just pick up tools, apply it to material in weird ways, and then you build you build a chair and you build this and you build that, right? And that's what made me fall in love with making to begin with. So when we started Machina, really I was combining two of the passions. Like I loved making things, and I was like, but then academically I was on the robotic and AI side. So like, can we make a robot that be a blacksmith and can be a carpenter? And to some level, I think it's a meta level of creation, right? Where you'd be like, okay, maybe that is my expression in this world. That is what I want to create. That is what's something exciting to create. So I guess back to your question, I do think that the core of the inspiration comes from that, arts and craft distributed nation manufacturing, right? I was like, okay, can we replicate this for this new generation for this new century, right? Where robots and AI is a thing, right? What is the reincarnation of craftsmanship? What is reincarnation of distributed manufacturing and arts and crafts? And I think it's going to be robotics and AI doing it, right? There's a lot of interesting work we do with artists now. Some of it actually was in NVIDIA GTC this year. There's an artist who was an artist in resident at OpenAI. Now he's at Meta, and he's exploring full creation with AI, right? Like, so basically ask an AI through prompting and conversation with it to make a physical object and it comes up with it, and then works with the systems like ours to actually make it into reality. So you go from like really intention and design and thoughts into actual physical product being produced in a matter of hours after that with a robot.
That's pretty
right?
cool.
And I think that is basically the same spirit. Like, like as a craftsman before, you had some thoughts and you're on to use your hands, and then a matter of hours later, you had the product that you wanted to make. Now we created this whole thing that like we just need to sit in a chair and think, and that thing will make it for us, right? So
It's cool.
it is the kind of the next level of craftsmanship, in my opinion, right? And that's what got me excited about it. Right?
Cool. All right, my man. All right, real quick rapid fire for you, and then we'll wrap it up. Okay, ready?
Awesome. Yeah.
Last book you've read?
So a book. Sorry, I know you said rapid fire. I read multiple books
Or
at
you
the
are
same
reading?
time. Yeah. So I think the last one I was reading was The Selfish Gene, and then I am also reading Shobo Genzo, which is like a historical, like a very old Zen book. Those are the last two.
Last podcast you listened to?
The last one I listened to was actually a conversation because we have Monroe here, Sandy Monroe here. So I was listening to this conversation he had with Elon Musk because I missed that one and he was coming. I want to make sure I have some context.
Cool. Last one. Tell the audience one person's work who you follow pretty closely that just inspires you. Can be any topic, can be any part of life. Doesn't have to be work related.
Yeah. I think it's cliche, but obviously, like, I work at SpaceX. I have a lot of respect for Elon, and I think, he's doing a lot of great work now for kind of, I think of it as, I think of Elon as a kind of unlikely mentor for America.
Sure, totally.
I was not, when I went to SpaceX, I was not thinking that way. And I think I learned so much working at SpaceX. It was through a lot of pain and trials. And, I slept in conference room tables to make things happen. But it taught me so many things in terms of how to take risk, how to value the work that you need to do, how to get to the final thing fast as possible. And I think America has lost a little bit of its mentorship culture, and I think Elon is kind of becoming this unlikely mentor to show, okay, what we were about, right? And that we can be that again. Again, I'm hoping that he doesn't go too much to the dark side, but I think so far he's been able to, I think, create that kind of excitement, that level of, at least among a lot of people, that level of like agency that I think we were lacking, going from that fear-based mentality into mindset of abundance. I'm hoping he can stay to track because everybody's fallible. At some point, people might do something that is crazy or stupid and overuse their powers. But I think so far I've been pretty I've been admiring what he's been doing and definitely learning a lot from it.
Cool, man. All right, tell everyone where they can find you at, where they can find you or Machina.
Yeah, I think Twitter, Edward Mehr, one word. LinkedIn, Edward Mehr, one word. I think those are two places I usually just post and chat.
Cool, man. Well, hey, man, I really appreciate you taking the time, and we'll include all the contact info in the notes.
Awesome. Thanks, Jordan. It was a great conversation.
Thanks, man.
All right, cheers.